The James Webb Space Telescope, JWST, is a powerful tool that allows us to explore the universe in greater detail than ever before. Last month, the telescope's cameras captured some of the most detailed images of the cosmos that we have ever seen. These images are absolutely stunning, and they provide us with a wealth of new information about the universe. From the formation of galaxies to the birth of stars, the JWST has given us a front-row seat to some of the most important events in the history of the cosmos. We are truly lucky to have such an incredible tool at our disposal. With the JWST, we can finally begin to unlock the secrets of the universe. So in this video, we will see how the James Webb Telescope captured an unexpected image of Jupiter, which shocked the entire industry. The Juno spacecraft has been orbiting Jupiter since 2016, sending back stunning images of the gas giant and its moons. But now, thanks to the James Webb Space Telescope, JWST, we are getting an even closer look at Jupiter and its family of moons. The JWST is a powerful telescope that is able to see things in great detail. In new images sent back by the telescope, we can now see Jupiter and its moons in incredible detail. The images show Jupiter's swirling clouds, as well as the giant planet's four largest moons, Io, Europa, Ganymede, and Callisto. We are thrilled that the James Webb Space Telescope's incredible ability to see fine details has been demonstrated in its first light observations, said John Mather, the JWST Senior Project Scientist at NASA's Goddard Space Flight Center. These results show that JWST has the planned performance we anticipated and will enable discoveries we have not even imagined. The images were taken over a period of several months, and they show a variety of different objects in the telescope's field of view. The asteroids in the image are all located in the main asteroid belt between the orbits of Mars and Jupiter. The Jupiter image was taken when the planet was just over 400 million miles from Earth. The data from these observations will be used to help calibrate the JWST telescope's instruments. This is important work because the JWST will be used to study some of the most distant and faint objects in the universe. The images were taken with the telescope's near-infrared camera, NIRCam. The James Webb Space Telescope's infrared camera has captured some stunning images of Jupiter. These images reveal the giant planet's swirling cloud tops in unprecedented detail, and they offer new insights into the mysterious dynamics of Jupiter's atmosphere. The Great Red Spot is a massive oval of red-colored clouds in Jupiter's southern hemisphere that has been raging for at least 400 years. Along with the Great Red Spot, Jupiter's striking cloud bands are also visible in this image. These bands are caused by jets of air that flow east and west at speeds of up to 600 miles per hour. The jets create disturbances in the atmospheric layers, which results in a distinctive banded appearance. These images display the full range of what Webb is able to see, from the faintest, most distant observable galaxies to planets in our own cosmic backyard that you can see with the naked eye from your actual backyard. The detail in these images is truly astounding, and they provide us with a new level of detail and understanding of Jupiter and its place in the universe. The James Webb Space Telescope is a highly adaptable tool that astronomers will use to investigate a range of cosmic objects and phenomena, including some in our own solar system. The telescope's primary mirror is made up of 18 hexagonal segments that work together to collect light from across the electromagnetic spectrum. This makes the James Webb Space Telescope ideal for studying everything from distant galaxies to exoplanets. In addition to its primary mirror, the James Webb Space Telescope also has a secondary mirror and an instrument module. The secondary mirror is used to reflect light into the instrument module, where it is focused onto detectors. The instrument module contains 4 science instruments: the Fine Guidance Sensor near-infrared camera and multi-object spectrometer, the mid-infrared instrument, the near-infrared camera, and the Fine Guidance Sensor near-infrared spectrograph. The Hubble Space Telescope has been in operation for more than 30 years, and during that time, it has offered a different perspective of the universe due to its capacity to gather light at infrared wavelengths, which are redder than visible light. In these images, Europa, a moon with a likely ocean beneath its thick icy crust, is clearly visible on the left. Also visible to the left of the Great Red Spot is Europa's shadow. Tabe and Metis, two additional moons, can also be seen in these images. These images offer a unique perspective of the universe and provide valuable insight into the nature of Europa and its potential ocean. The new images captured by the JWST technology show that satellites and rings can be observed close to bright objects such as Jupiter, Saturn, and Mars. The JWST will be used by scientists in order to investigate the claim that material plumes can be observed erupting from moons like Europa and Enceladus. This is an interesting claim because it has the potential to give us insight into the internal workings of these moons. Webb might be able to observe the distinctive marks left by plumes that have deposited material on the surface of Europa. This is one of the solar system's coolest applications for this telescope because it has the potential to shed light on the mystery of these moons. But what was unexpected was a large amount of data Webb collected about very faint objects in pictures with 1-minute exposures. Webb also took pictures of Jupiter and Europa while they crossed the telescope's field of view on 3 separate occasions. Webb started the moving target tracking speed limit tests using the asteroid 6481 Tenzing, which is located in the asteroid belt between Mars and Jupiter. The asteroid was chosen because it is one of the largest and brightest objects in the asteroid belt, and it was moving relatively quickly at the time of the tests. The tests showed that the observatory can track a moving object, like an asteroid, in near real time. This is an important capability for Webb, as it will allow astronomers to quickly follow up on newly discovered asteroids and comets. On December 21, 2016, Juno performed its 41st flyby of Jupiter and reached a top speed of 130 miles per hour relative to the planet. This flyby was faster than any of Juno's previous flybys and more than 7 times faster than the International Space Station's orbit around Earth. During the flyby, Juno's instruments, including the Juno Cam, collected data and images of Jupiter. These raw images were then processed and uploaded to an image processing gallery where citizen scientists could add their own perspectives and analysis. The images and data collected during this flyby will help scientists to better understand Jupiter's radiation belts, as well as the planet's magnetic and gravitational fields. Even though Jupiter was Juno's first primary target, NASA gave the okay to change the mission's focus in January 2021 to look at something else more closely. Webb's object tracking team decided to use Mars as their standard for comparison because it has a maximum speed of 30 billion miles per second. During commissioning, the team observed several asteroids. Because they were all small, they appeared as dots in the footage. The team showed that even for objects moving up to 67 billionths of a second per second, the Webb telescope will still be able to receive useful data, more than twice the baseline. Jupiter is a spinning world, as seen in breathtaking footage from the Juno spacecraft. The footage, taken on April 9, 2022, shows the Juno spacecraft traveling only 250 miles above the gas giant's clouds. The view is an accelerated perspective, similar to photographing a turtle crawling when you're standing a mile away. This allows us to see Jupiter's rotation, as well as the patterns in its clouds. So there you have it, guys. I hope you found this video interesting and informative. And if you have any questions or comments, I'd love to hear from you. Thanks for watching, and I'll see you in the next video.